Hey there, welcome to class notes on lesson 7.4, solving polynomial equations in factored form. Here we go. The first warm-up you're going to have is to solve both of these problems. Go ahead and solve them now, pause this video, and then come back in 5 seconds and see how to do it. Alright, now that you've come back because you actually solved the problem on your own, make sure that you are solving these correctly. So for the first one, you can drop the parentheses, you will subtract that 8, so you'll get 2x is equal to negative 8. Divide both sides by 2, you're going to have x is equal to negative 4. For the right one, we have to add the 7 to both sides, so we have 3x is equal to 7, with the final answer becoming x equals 7 over 3, a fraction. Remember that when we say solve, it means get x by itself. So you're figuring out what value can you plug in to make this equal to 0. Always actually do the work, don't just try to guess and check your answer. So here are the learning targets for 7.4. We're really going to hone in on zero product property today, as well as factoring using the greatest common factor. So we have looked at a few things, and now that we're farther into Chapter 7, we're going to dive a little bit deeper. So you guys have already seen standard form. You know that it means it's something in order. When we call something factored form, we mean that we have factored something out. We have removed something that multiplies into both pieces. So you notice with x squared plus 2x, you can factor out an x because there's an x in both of these pieces. Therefore, you have x times x is x squared, and x times 2 is 2x. Likewise, you guys have actually already been multiplying binomials to get them into standard form. And now we're going to start working the other direction. So we can start to figure out if we have something in standard form, how do we get it down to factored form, and then how do we find the answers. The idea of the zero product property tells us what is the answer of the x value when it crosses the x-axis, also known as a root. So when we look at these, we're going to solve these just like our warm-up. The only difference is this time, instead of just solving one piece for 0, we need to solve either one of these pieces to be equal to 0. Because we know anything times something being equal to 0, that means one of these two things has to be equal to 0. So we could have 2x is equal to 0, which would then, when we divide by 2, we get x is equal to 0. Or we could have x minus 4 equaling 0. Notice you're taking both parts and you're setting both things equal to 0. So this is the idea of the zero product property. 0 times anything is 0, or anything times 0 is 0. So our two answers here would be x equals 0 and x equals 4. Likewise, over here, again, we'd split this into our two different types. So I could have x minus 3 equals 0, which would mean one of my answers would be x equals 3. And my other answer could be x minus 9 equaling 0. So therefore I have 9 as my answer. Sometimes you get repeated roots. So if you have anything that has an exponent to it, you're going to have a repeated root to these. So as we work these through, this first one here, we have 2x plus 7 equals 0. Subtract 7 from both sides, so you have 2x equals negative 7. Therefore, our final answer is x equals negative 7 over 2, which is the same thing as negative 3.5. For the other half, 2x minus 7 equals 0. Add 7 to both sides, we get 2x is equal to 7. Final answer becomes x equals 7 over 2, again the same thing as 3.5. Now our next one has a exponent with it of a value of 2, meaning that if you were to multiply this out, technically you would have x minus 1 times x minus 1 equaling 0. But in both of these cases, it would be the same solving pattern, so you're just doing x minus 1 equals 0, and therefore your final answer here would just be x equals 1. Likewise, for our last one, we have to solve each of these independent pieces inside to be equal to 0. So your three answers for this would be x equals -1, x equals 3, and x equals 2. So you have three different answers. Noticing here we have three different things being multiplied, therefore we have three answers. Here we had two things being multiplied, we have two different answers. Here we technically have two things being multiplied, but because they're both the same, we only have one repeated answer. So factoring using the greatest common factor simply means you're going to pull something out that has the greatest common factor between those two things. So for example, if I had written out 25 plus 15n, I could divide both the 25 and the 15 by a 5, so I could pull a 5 out, and then I would be left with 5 times 5 plus 3n. 5 is the biggest thing that multiplies into both of these pieces, both of these terms. Therefore, I can factor this, and now I can apply the zero product property much more easily. So if we have something like this one, find the greatest common factor of this, we say what goes into both of these. So you'll want to look at the constants first. So for 4 and 24, well, the biggest thing that multiplies into 4 is 4. 4 multiplies into 24, so we would take out a 4. Then we say what multiplies into x to the fourth and x to the third. In both of these, we would have an x to the third, and we'd be left with a singular x plus 6 to multiply on the inside. Because 4x to the third times x is 4x to the fourth, and 4x to the third times 6 is 24x to the third. Alright, lastly we have two more problems to look at, and then we'll be done solving these. So for problems, you always want to have them set equal to 0, so you'll notice b is not set equal to 0, so we'll do that in just a second. But once you have them set equal to 0, you want to try to factor these even more to make it easier to solve. So in this case, we can factor this down to pulling out a 2x in front and having x plus 4 equaling this to 0. You'll notice as we work through these different parts, 2x equals 0 would be x equals 0. Or if we have x plus 4 equals 0, we would have a -4. These are our two answers that could be plugged in to get 0 to work. For b, we'd want to rewrite this one. So instead of writing it as n squared, 6n squared equals 15n, we would want to rewrite this as 6n squared minus 15n equaling 0. And then from there we factor it. 3 multiplies into both, so we'd divide out a 3. N multiplies into both, so we divide out an n. We'd be left with 2n, because 2n times 3n is 6n squared, and we'd be left with a -5. This one obviously will not be as easy to solve, so we do 3n equals 0. So we have an n equals 0. And then when we have 2n minus 5 equals 0, well, this would become 2n equals 5. Divide both by 2, so we'd have 5 divided by 2, which is the same thing as 2.5. So our two answers here become n equals 0 or n equals 2.5. Again, we get 0 because we technically had 3n equaling 0. Divide both by 3, you get n equals 0. That's it. You got some homework. Get those reps in. That's how you get better at anything, is actually by doing some practice. If you need help, let me know.